Hi everybody. So today we're going to start our next unit. So this unit is going to address energy resources. So we're going to start off with chapter 19 on fossil fuels. So basically I just want to give you a little bit of review and some overview of fossil fuels. And then you're going to do a little web quest to learn more about the individual types of fossil fuels. Okay, so some quick review. We talked a little bit about energy way back when we talked about the living world. Can't remember which chapter it was, but just some terms that you should remember. So if you don't remember exactly what these are, go back to your notes and look at them. So we want to think about energy, so potential versus kinetic. So energy that is stored versus the energy of movement. And then don't forget those two laws of thermodynamics, right? So energy can't be created or destroyed, but it can be transferred from one form to another. And that's what a lot of our discussion of how these energy sources are used, we're going to talk about how it's transformed from one type to the other. Okay, and a big part of that is transferring the kinetic energy to electrical energy. So basically, what you're going to do in almost all of these types is figure out a way to turn a turbine that's attached to an electromagnet. And moving that magnet through wire coils is what produces the electricity. Okay? And the fewer steps in this transformation, so when you go from where your starting point is and how many types of transformations there are, the more efficient it is. So the fewer steps, the less energy is lost from the system. Okay, and just a little bit about sources of energy. So probably you all know the sun is the ultimate source of a lot of our energy. So when we talk about living systems, right, this is where almost all, except for a few exceptions, are going to get their energy from those photosynthetic producers, right? But it also is a source of our energy that we get. So it could be solar energy. Don't forget, though, the sun also drives things like the winds, right? And it's responsible even for fossil fuels because those fossil fuels were at one point either organisms or plants that were growing. So that's how that carbon actually got sequestered, was through photosynthesis at one point in time. And so those fossil fuels are highly combustible substances formed from the remains of organisms from past geologic ages. So I always like to stop and think, fossil fuels, these are actually fuels from fossils. Like, I don't think we actually think about that, but that's where the name comes from. All right, our three main fossil fuels that we're going to discuss are coal, oil, and gas. Okay, so that kind of encompasses this. There are some other sources we're going to get to in later chapters. So there is some energy that comes from the Earth's core, and we can get geothermal energy from that. There's energy from the gravitational pull, and that can be the ocean tides, so between the moon and the Earth. Bonds among protons and neutrons, that gives us our nuclear power. All right, and then the other things I want you to remember is go back and review renewable and non-renewable sources. So as we've talked about so far, things like sunlight, geothermal, and tidal are renewable, and then our non-renewable are our fossil fuels. So if we want to remember, our renewable resources are those that can be replenished naturally at or near the rate of consumption and reused. All right, while our non-renewable resources exist in a fixed amount and involve energy transformation that cannot be easily replaced. So fossil fuels took millions of years to generate. So even though technically new ones could be forming, there's no way that the rate of us taking it out would equal the rate of formation. Okay, make sense? Okay, the other thing to think about is it takes energy to make energy. So you have to invest substantial inputs of energy to get energy out, which you have to kind of think about for a minute, but think of it. You have to mine it, process it, pipe it somewhere. Maybe you have to store it. You have to provide housing for workers. You might have to refine it. So depending on what type of fossil fuel we're talking about, all of these different steps may involve different things. So when we're evaluating energy sources, we want to take this into account. So think if you're an investor, right, investing your money, you want to get the best return. So you know you have to put some money in to your investment and you want to get more money out. So that's the same idea with energy. So the net energy is the energy returned minus the energy invested. Okay, and we can also talk about this energy returned on investment, and that's the ratio. So it's the energy returned over the energy invested. Okay, and if you think about how this works, the more energy you get out of it, right, the higher this ratio is going to be. So that either means you invest very little or you get a lot back. But if this ratio is high, then that means you receive more energy from each unit of energy that we invest. All right, and fossil fuels historically have had high EROI energy ratios because we get a lot of energy out of them. They're very efficient in that way. This also, though, can change over time. So as we start depleting some of our oil wells, for instance, we may have to invest more energy to drill deeper or to use different extraction methods. We may have to invest more money to drill offshore, and it may cost more money to make an oil platform. So over time, this changes. And this actually we'll see in the U.S., for instance, right now, since people aren't using oil as much, gasoline prices are dropping. And when oil prices drop, then the oil that we get, like from Canada or that people are getting from fracking, that all of a sudden costs more to produce than it's worth because the energy is too cheap. So think about if that makes sense or not. Okay, so fossil fuels, as we said, are formed from ancient organic matter, and it varies a little bit. So coal comes from woody terrestrial vegetation, and oil and natural gas come from marine organisms. But basically the idea is the same. You get heat and pressure, and over time, you get these formations of fossil fuels. And where these formations form vary because it needs these conditions here and also the conditions as they're decomposing to be the right conditions. Okay, as I said before, they have a high energy content. And then because these are all coming from organic matter, they all have varying amounts of carbon. And so they all emit CO2, which we know is a greenhouse gas. All right, fossil fuels are the most widely used sources of energy globally. So you can see oil and coal are the top two. Coal has really increased probably in the last, 30 years or so. And a lot of this is from China, but the U.S. also produces a lot of coal. Oil has been a little bit more steady, and natural gas has actually increased as we've developed new technologies to access that. All right, the demand for energy increases as the world becomes more industrialized. And when you think about things like availability, price, government regulations, all of these things influence which energy sources people use and how they use them. Okay. All right, so energy is also, as I sort of mentioned in the previous slide, is unevenly distributed because of the geologic history. And the rates at which you consume the energy also vary. So if we look over here, we can see coal. Well, the U.S., look, U.S., Russia, and China have most of the world's coal reserves. Oil, Venezuela, Saudi Arabia, and then Canada. So we'll talk a little bit about this later on. And then natural gas, and here again, the United States has really grown in our natural gas production because of hydraulic fracturing in a lot of areas. All right, and here's the map showing consumption. So look at this. If you look at the scale, so red is the highest. So us and Saudi Arabia. So we're the highest. And then you see other Western countries are also fairly high, though quite a bit lower than us if you look at it. But developing areas, so almost none of it is coming from various parts of Africa yet. China, though it's developing, is still yellow, but there's a lot that as their population becomes more and more westernized, you could expect this to increase. Okay, so developed regions in general consume more than developing nations. And this is just an interesting statistic. The US has only 4% of the world's population, but it consumes nearly 18% of the world's energy. So that's a fifth, almost a fifth of the world's energy. All right, and then we vary a little bit in how we use energy. So industrialized nations basically split it about three ways. So transportation, industry, and then other uses. Whereas industrializing nations, they're really focusing a lot on subsistence activities. So not so much on sort of transportation and industrial uses. And I'll just point this out here. You're going to look at this more on your WebQuest, but the different sources of fossil fuels contribute to these areas in different ways. And I'll just point out here, look at natural gas. Natural gas you can use for almost every type, so it's very versatile. Coal is mainly used for electric generation, for instance. Okay, so take a look and sort of how those fossil fuels divide themselves. All right, and since these are fossil fuel reserves, right, we are taking it out of the ground, so we're depleting it. So people talk about the reserves to production ratio. And this gives us a way to think about basically how long we think our reserves are going to last. And this varies a little bit, but right now these are sort of the figures people get. And one of the things you can do when thinking about these supplies, think about both the consumption and the demand. So you can address both of these, right? You can reduce consumption, which would increase this. Reduce consumption, which increases this. Or reduce demand. So depending on what we're doing here affects what we're doing here. New deposits are always discovered and extraction techniques improved. So when I was going to school, this was actually people were really talking about like oil disappearing. And then they found new sources and new extraction techniques, and all of a sudden this really expanded into the future. All right, but at any rate, you do hit this point where the extraction will come to a peak and then decline, and we call that peak oil or peak gas. And after this is when you can expect prices to really increase because the demand from consumers is really there, but we're not basically producing it as much anymore. All right. And so as we sort of deplete our resources, we have to reach further for fossil fuels. And we'll talk about these in a little bit more detail, but this is just sort of a list. So mountaintop mining has been a way to get to more coal. We've actually been able to go back to existing wells that were sort of tap dry, but now that we have better technology, we can do more secondary extraction. Directional drilling is drilling horizontally. We talked a little bit about hydraulic fracturing. Offshore drilling is moving into deeper and deeper waters. And then here's another sort of consequence of global warming. As the Arctic becomes more ice-free, then drilling is moving into various parts of the Arctic as well. And then we're exploiting things like oil sands, oil shale, which is what's happening in Canada and a lot of their oil production. And then this is really just sort of theoretical so far, is how to use methane hydrates to get natural gas, basically. Okay, so that's just a little bit of a intro into fossil fuels. And what you'll do now is you'll watch some really quick videos and answer some questions about each of the types of fossil fuels. All right, have a great day.